Hey everybody, welcome back to another Fix My Lab Challenge solution video. The two things I was trying to educate you on within this lab were Vlan issues and floating static routes. Let's get started by looking at our Vlan issues. So the link here between Core0 and Switch0 is actually a trunk link. And as you may know, trunk links have something called a native VLAN, which is the one untagged VLAN going across that trunk link. And your native VLANs should always match across trunk links for a few different reasons. So here I configured Switch0 with a native VLAN of 10 and left Core0 with its default native VLAN of 1. And with that type of configuration, any traffic leaving this switch on VLAN 10 is going to be merged into VLAN 1. So number one, that's just going to black hole traffic for VLAN 10 endpoints because they're not going to have the right IP space, but also this poses a security threat because I would never want endpoints on one VLAN to accidentally be merged into another VLAN. So always make your trunk link native VLANs match. There's two ways to fix this issue in the topology. You could have either made Core0's side native VLAN 10 and then it'd be 10 and 10, or remove my native VLAN 10 command and Switch0 to make it back to the default of 1. So if I do show interface trunk here you can see the native VLAN is 10 on Switch0's side, and then if I go to Core0, you can see that it's 1. So I'm going to fix it on the Switch0 side just by saying no switchport trunk native VLAN 10. And that will put it back to having the default native VLAN of 1, which will make it match Core0. Alright, now that that's fixed, the next VLAN issue we had was on Core1 over here. So here I simply just did not add VLAN 11 to Core1 here, which VLAN 11 is the network that PC1 is on. So without the VLAN existing, if I do show interface VLAN 11, which is the layer 3 gateway interface for that network, you can see that VLAN 11 is down. Well, if a switch doesn't have a VLAN in its VLAN database, then it cannot bring that layer 3 interface in the up state. So this is preventing PC1 from communicating with anything off of its local network because its gateway is not operational. So I'll fix that by just adding VLAN 11, and you can see right away the SVI went in the up state. So now that that's fixed, I believe the PC should be able to ping each other. So I'll go to PC0, have to wait a second for ARP to populate, and there we go. So we fixed the native VLAN issue over here and added VLAN 11 here, and now we have IP connectivity between our PCs. Now that that's good, if you look at the success criteria, the ping packets between these PCs should take the primary path via router 0. So here I have labeled primary path and secondary path. So to see which path these pings are taking, we can use Traceroute. For those of you that don't know what Traceroute is, it's a IP connectivity tool that can be used to actually show you which routed path your packets are taking. So I should see in this output that my packet hits my gateway and then hits, I believe this IP is .2, and then this one is .10. So let's run our traceroute. In a Windows command prompt, you can run traceroute with the traceroute command, short for traceroute. And if you look at this, we hit our gateway. Look, we would expect. And then we go to .6, .14, and then to our destination. Well, if we look at our topology, that is taking our secondary path because we hit our gateway. We go to .6, which is right here. And then I think this is .14 on this link. .14, and then our destination. So that is not meeting our success criteria because both links are up. Under normal circumstances, we should go this way. So the reason it's going this path is because I mixed up the administrative distance values that were configured on our static routes. So if I do show run and look at our static routes, we see that we have this static route with the default administrative distance, which is 1 for static routes. And then on the path I want to be primary, I have an administrative distance of 200, which is way worse than 1, obviously. So the router is naturally going to choose this path and install this path as a floating route. For those of you who don't know, a floating static route is simply a route that's configured but not in the routing table. And the purpose of them is to be installed if your primary path goes down. So if I do show IP route, you see that it's installing the static route with a default AD of 1 via our secondary path. So all we need to do is make this route have an administrative distance of 200, since that's the one we want to be floating, and then change this route back to the default AD of 1. So I'll paste this route back in. I think I can just paste it in without the administrative distance of 200. Let's make sure that that looks good now. Okay, so now the primary path route looks good. So .2 again is router 1's IP right here. All right, so now I have to change this static route to be our floating route by giving it a higher administrative distance than our primary route, which you can use anything above 1. I happen to use 200 in this case. So I'll just copy this route, paste it in, and then at the end, if I do question mark, there you can see how you can give it your administrative distance values. So I'll do 200. And now, if we look at the routing table, you'll see that it installed our primary route path via router 0, just like we wanted. So that looks good. And I also made the same changes going this way, so we have to actually correct the same thing on Core1. So I'll do show run to look at the configuration, and here you can see that the values are mixed up here as well. So again, I'll copy this, paste it in without the 200 value, and then add the 200 value to this route. So now if I do show IP route, I see that it's preferring the path via .9, which is our primary path, just like we wanted. So now by default, traffic flowing in either direction should flow across our primary paths, just like we wanted. Even though things look good from a routing table perspective, let's actually test this by simply shutting down router 0's interfaces. And when we do this, we should see both cores install the floating route via router 1. Shut. So clearly the path is down up through router 0. So if I go to core 0 and do show IP route again, it looks like it successfully installed our floating route going to .6 here. And then hopefully we see the same thing on Core1. And we do. All right, so now let's test. Make sure that even in a failed state, our devices will have connectivity across this topology. Okay, so that looks good to me. We'll do a ping, even though a traceroute looks good. And we're good. So we've met our success criteria. Under normal circumstances, traffic flows through our primary path, but in a failed state, it will be able to fail over and use our floating routes across our backup path. All right, that's it for this solution video. Thank you again for participating in this Fix My Lab challenge. Don't forget to hit the subscribe button so that you're notified for any future Fix My Lab solution videos. Take care and have a great weekend.